So a complex fraction can look and seem kind of confusing, but it's really not too terrible. So a complex fraction looks like what we see here. Um, it's a fraction within a fraction. So our numerator is a fraction, our denominator is a fraction. Um, so instead of just having like something over something and making it a fraction, we have two separate fractions. Okay, not a big deal. What we're going to do with this is rewrite this as division horizontally. So right now, this is a over b over c over d. So this line here, this over line, this is our division bar, and we can rewrite it horizontally. So we have a over b, and then divided by c over d. So by changing the way that it's written, it makes it a lot easier for us to solve since we know how to do division this way. So as a reminder, when we have division, we stay switch flip and we change it to multiplication. So we have a over b, that's going to stay. We're going to switch our division sign to multiplication, and then we're going to flip our second fraction. So d over c. So now we look at this like a regular multiplication problem and we try to see if we can cross cancel or simplify anything, and we can't. So we're just going to multiply this straight across. So we end up with AD over BC. So we're going to take this idea of rewriting these uglier complex fractions as regular fractions with division. So let's look at something a little bit more challenging. So we look at this. It's very similar to the other problem. Yes, there's more to it, but it's the same idea of having a fraction over a fraction. So first thing that we'll do is we'll rewrite this. So we have 8x squared y over x plus 1, and it's divided by 6xy squared over x plus 1. Since we have it written horizontally now, we can stay switch flip and change it to multiplication. Now, if you don't even want to write this step and you want to go right from the complex fraction to the multiplication, that's fine. Okay, you don't need to write it this way. I just want to show you where I'm getting things from. So we're going to stay this fraction, and then we're going to switch the operation to multiplication, and then we're going to flip the fraction. So we're going to have x plus 1 over 6xy squared. Okay, so from here, we're going to try to reduce, simplify, cross cancel, anything that we can do to make this easier. So I can cross out the x plus 1s because they're going to divide out. If I look the other way, the 8 and the 6 can both be divided by 2. So I'm going to divide 8 by 2, so I have 4. And then I'm going to divide 6 by 2, so I get 3. I have x squared and x, so this x is going to go away, and this x squared is just going to become an x. Y and y squared, same idea, so this y is gone. This y squared becomes y. So now when we multiply across, we have 4x over 3y, and that is our simplified answer. So then, just like we do for everything else with rationals, we have to make sure that we include our domain restriction in our answer. So because this is a division problem, we want to go back and say we need to set the bottom of the first to 0 and the top and bottom of the second. So because it is a division problem, the denominator of the second fraction was x plus 1 in the beginning. When we flipped it, the 6xy squared became the denominator. So both of these were denominators at some point. So we're going to take the bottom of the first and set it to 0. So x cannot equal -1. We're going to take the top and bottom. So top we're going to set to 0. We get -1, so we already have that. And we're going to set the bottom, so the 6xy squared, set that to 0. So if we set 6xy squared to 0, and we're solving for x in that case, we're going to end up getting that x cannot equal 0 as well. But we have two variables, so we also have to solve for y. So y can also not equal 0. So we have our restrictions as x cannot equal -1 and 0, and y cannot equal 0. Okay, so let's look at another one. Again, a fraction over a fraction. So what we're going to do is we are going to rewrite it as division horizontally. So we're going to say it is 9m plus 6n over m squared n squared, and then divided by 12m plus 8n over 5m squared. So we have division, so we're going to stay switch flip and make this multiplication. And again, if you wanted to skip this step of making it division, you could, as long as you stay switched flipped it correctly. That's fine. So once we have it as multiplication, we want to see if we can cross cancel anything, but we always want to make sure that we factor anything that can be factored first. So when we look at this, I can factor this numerator and I can factor this denominator. So the numerator, 9m plus 6n, I can pull out a 3, that's my GCF. So I have 3m plus 2n. The bottom can't be factored, so I'm going to leave it as m squared, n squared, times the 5m squared we can't do anything with, so we'll leave that. And then the 12m plus 8n, take out a GCF, in this case it would be 4. So we have 3m plus 2n. So once we've factored everything completely, we're going to try to cross cancel or simplify. So 3m plus 2n is gone. When we look this way, the m squareds are going to be gone. And we can't do anything else. So we're going to multiply across. So on the top, we have 15. And on the bottom, we have 4n squared. And then we can't forget our domain restrictions. So since this was division, we're going to do bottom of the first and top and bottom of the second. So if we set m squared, n squared equal to 0, we're going to solve for m and we're going to solve for n. And m cannot equal 0 and n cannot equal 0. If I set 5m squared equal to 0, again we get m can't be 0, which we have currently. And then our last piece, the 4 on the outside, we can't make that 0. So we're really just setting the 3m plus 2n equal to 0. Now here, because there are two variables, we have to solve for m and also solve for n. So I'm just going to write it on the side so you can kind of see here. So 3m plus 2n equals 0. So if I want to solve this for, let's say m, I want to get m by itself, I would subtract 2n on both sides. So I get 3m is equal to -2n, and then I divide both sides by 3 to get m by itself. So m can also not equal -2n over 3. So similarly, if I have the same setup, but I subtract 3m, and then I divide by 2, n cannot equal -3m over 2. So these would be my, restrictions. Ooh. Pretend that that's good. Those would be my restrictions. Now, what happens if we have addition or subtraction involved with one of the fractions? Well, we can do one of two things. So I'm going to kind of show these problems both ways. The way we've been doing it using division, you can definitely do. The more complex that these get, with more addition and subtraction happening, which we'll see in a minute, those might be easier to do a different way using the LCD. So let's look at this first the way we looked at it before. So if I want to rewrite this, I have 1 divided by and this would be 1 plus x over y. So I'm putting this in parentheses because I want to make sure that we keep this 1 plus x over y like together. If you need to, you can make this like 1 over 1, so you know that that's like the top fraction and this is the bottom fraction. So you always want to work with your parentheses first. If you have something where there's addition or subtraction, try to work on that first to simplify it. So when I have 1 plus x over y, this 1 is really like 1 over 1, right? So I need a common denominator here. So I'm going to rewrite this as 1 divided by, and I'm going to make the common denominator here be y. So I need a y here and a y here. So this becomes y plus x over y. Right, I just combined this fraction together. I really had y over y plus x over y. When I have that common denominator, I can add the numerator together. So now I'm going to stay, switch, flip, like I did before. And if you want to make this 1 over 1 to make this make more sense, by all means, go ahead. I can't do anything here. I cannot cancel these y's because this y on the bottom is attached to an x through addition. So I cannot cancel these y's out. So when I multiply straight across, I get that y over y plus x. And that is my simplified answer. And then just like with everything else, we need our restrictions. So here, again, since it was division, you can't set 1 to 0. So you're going to deal with the top and bottom of the second. So our restrictions would be that y cannot equal 0. That's from the numerator here. And then from the denominator, y plus x, set it to 0. So y can also not equal negative x, and x cannot equal negative y. So here are our restrictions. Now the other way that we can kind of think about this problem is using the lowest common denominator to kind of simplify it a little bit and kind of skip these steps in between. So if I have the same exact problem here, I can, let me add a new page here. So I had 1 over 1 plus x over y. So what I can do is I can look at everything that I have and think, what is my lowest common denominator? So it has to be y because the only denominator I have that's not 1 is y. So what I can do is I can multiply the entire numerator by y and the entire denominator by y because that's my LCD. So my common denominator in this case is y. So when I multiply 1 times y, okay, I get y. And then on the bottom, I'm multiplying the 1 times the y, so I get y. And then I multiply x over y times y. So the y on the bottom and this y on the top are going to cancel out, and I end up with just x. So I end up with the same answer I had before, and we'll go back and look at it real quick. Same thing, y over y plus x, y over y plus x. The difference here is that we're doing what we learned before, so we're getting that common denominator like the longer way, we're simplifying it the longer way, we're changing it from division to multiplication, and then we're solving from there. With the LCD method, you're looking at the common denominator first, and you're trying to get rid of the extra steps of having division by just jumping right to your final answer. And we'll look at a couple more that are similar to this. Now, you do not need to do this one way or the other. They both work, so if one works for you better, please use that way. This way is kind of more direct. It kind of follows the steps of what we did before. This way is something that most likely you will see when you get to pre-calc because you need to kind of do these a little bit faster. So this way will be a little bit better. We're going to go over some more in the next video.